Okay, chapter 6, section 3, we start to talk about the binomial theorem. The binomial theorem is based off of Pascal's triangle. So Pascal's triangle is going to be a triangle, and it's going to have numbers in it. But here is a little information on the Pascal's triangle, because I feel that you guys need a history of where this math came from. So Pascal's triangle is a famous number pattern named after the French mathematician Blaise Pascal, who was alive from 1623 to 1662. You can use Pascal's triangle to help you expand a power of a binomial of the form a plus b raised to the n. Use the tree diagram shown to generate Pascal's triangle. So we're going to, Pascal's triangle, of course, looks like a triangle. And there's a tree diagram in your book. And I'm also going to post a picture of Pascal's triangle, which goes on forever. There's only so many rows that is shown on the picture. We're only going to look at 3 rows here today, maybe 4. But it actually continues on forever and ever and ever and ever, all the way until as big as you need it to be. So if you had a binomial raised to the 100th power, you would be looking at 100 rows of Pascal's triangle. So it can still go on forever. So the first row, the tip of the triangle, is technically row 0. And that's going to be, it's going to start with a 1. And along the outside of Pascal's triangle, all the boxes are going to be a 1. And for this row 1, we're going to also have a 1. So you have 3 1s at the top of Pascal's triangle. So now we're going to look. We have 1 and 1. And then we have this 1 on the outside. But to get this box here in the middle, we're going to technically add. So 1 plus 1 is 2. And then we're going to also have a 1 on the outside here. So now once you have those first 3 rows, it is technically just going to fall all into place. So again, you'll have a 1 on the outside, and you're going to have a 1 on the outside. Then in the middle, 1 plus 2 is 3. 2 plus 1 is 3. And this pattern would continue on forever. You're going to have 1s on all of the outsides of your triangle. And then in the middle, you're going to add your 2 boxes in order to get those middle boxes. So when Pascal's triangle is pretty much complete, we have something that looks like this. We have 1s all along the outside going down in a TP. And then in the middle, you can see 1 and 1 gives me 2. 1 plus 2 gives me 3. 1 plus 3 gives me 4. We have 2 plus 1 gives me 3. 3 plus 3 gives me that middle box 6. And then we're also going to have a 4 here. So Pascal's triangle pattern, 1's on the outside. Usually the numbers in from the 1 are the same on both sides. And then in the middle is where the math happens. So this exact diagram is going to be posted in the week 11 folder for something for you to reference throughout the rest of this year and whenever we need it. And it'll be there, of course, for your semester exam. So if we look at Pascal's triangle and relating it to the binomials, we technically have something that looks like this. This is technically a little bit of probability as well. So Pascal's triangle brings in probability. And this is, you could find whatever coefficient you need by using a calculator as well, using the NCR button or NPR button on your calculator. But you're going to look at the NCR if we go to use a calculator. I don't know if I'm going to be giving you ones that are going to require a calculator as we go on through this. So row 0, you technically have 0, choose 0. Row 1, since we're in row 1, it's going to be 1, choose 0, 1, choose 1. And these will give you numbers if you were to pop this into a calculator. But we're going to use this in order to find these. as well as we're going to look at a plus b to the fourth, and then I will explain the binomial theorem itself. So, 0, choose 0, that means I'm looking right at the beginning of this triangle. So anything raised to the 0 power, if I had the binomial a plus b raised to the 0, row 0 on Pascal's triangle is 1. So your answer there is 1. A plus b raised to the first power, that means both a and b are going to be raised to the first power. So then you're just going to have a plus b. That's going to be your answer there. Now we talked about this when we were working with binomials in section 2. So we have a plus b squared. So you can go ahead and map that out like the FOIL method, or you can say, well, Pascal's triangle, I'm in technically row 3. So I'm going to look at my numbers for row 3. I have a 1, a 2, and a 1. So a is going to be by itself. It's not going to have any coefficient. Then you're going to have 2ab, and then b is going to be by itself. It's not going to have any coefficient. So 1, 2, 1. Then when you have a plus b to the third, this is where the binomial theorem starts to come into place. You're going to take technically this answer here and multiply it by a plus b. So you'd have a plus 2ab plus b times a plus b. If you were to do that mathematically, which we know how long that takes you. But you could also follow the pattern of Pascal's triangle, 1, 3, 3, 1. So that means my a is going to just have a coefficient of 1. Then I'm going to end up with a 3. My a is going to be squared. And my b, and this is going to come from the binomial theorem, which I'm going to show you here in a minute. And then plus 3ab squared plus b squared. So a squared plus 3a squared b plus 3ab squared plus b squared is when you multiply out anything raised to the third, a binomial raised to the third. So where is Ms. McAllister getting these exponents for the variables? Well, those are going to come from the binomial theorem themselves. So you have the binomial theorem, and it says for any number n, the binomial expansion of a plus b to the n is given by this long thing, and it continues on forever. This is no set rule. You can see in the middle here, you have a plus, dot, dot, plus. That just means that they've given you the beginning. There's a whole bunch of stuff in the middle, and it can go forever, just like Pascal's triangle. So your coefficient, the n, and then it's going to have a c, and then have 0. That's where we're going to start. So if we were looking at row 1, if we were raised to the first power, that's going to be whatever coefficient's here. So that's a 1 in Pascal's triangle. And then it'll be a to the n. So a is going to be raised to whatever your n is. In this case, it's 1 because you're in row 1. And then b to the 0, which is 1. So that's why b doesn't technically exist next to this a. And then we'll have plus n, choose 1. So you go over here. If we were looking here, and that would be your other coefficient. And that's where we get the b. So if we look down, and let's just look around for the 4. So if we were to use this for a plus b to the fourth, I'm going to look at the fourth row. So I have 1, 4, 6, 4, 1. Okay, I'm going to technically look at row 4. So 1, 4, 6, 4, 1. So I'm just going to jot those down. 1, 4, 6, 4, 1. Those are going to be my numbers that are going to be my coefficients. So I'm looking at, if I was to look n, so it would be 4, choose 0. My first coefficient is 1. So a, I'm going to have a 1, and I'll just have a to the n. Since we are in 4, it'll be a to the fourth. And then b is going to be to the 0, so b is not going to exist. Then if we look n, choose 1, so if we look at the next number, so that's going to be a 4. And then a is going to be to the n minus 1, so a would be to the third. And then b is going to be to the first, so that's just going to be b. Then the second one, so we're going to do 6. And we'll have a to the second, b to the second. So a to the n minus 2, so 4 minus 2. And then b to the second. And then that pattern is going to continue. I'm going to have a 4. And I'm just going to have an a, because it would be technically 4 minus 3. And then my b is going to be raised to the third. So we're down here at this part. And then we would have, for our last one, we're just going to have b raised to the fourth. So it's going to start with whatever row you're in. It's going to end with whatever row you're in. And that would be the expansion of a plus b to the fourth right here. 1, 4, 6, 4, 1. And then your exponents go down. And then they pick back up in the b. So we're going to do a couple more examples like this. So using the binomial theorem, we want to expand x minus 2 to the third. So technically x is my a, negative 2 is my b, 3 is my n. So this time we have that negative 2 to incorporate. It's not just a positive binomial. So step 1, you want to identify the values in row 3 of Pascal's triangle. So we have row 0, row 1, row 2, row 3. So my values are 1, 3, 3, 1. Those are going to be your coefficients. Then we want to expand using the binomial theorem. So we're going to say x minus 2 to the third is going to equal whatever my first coefficient is. So it's 1. Then it'd be x to the n, so x to the third. And then it's going to be b, which is negative 2 in this case. And that's going to be raised to the 0 power. Then we are adding. We're going to say 3. And we're going to say x to the second, because we're going down 1. And then that b is technically going up 1. So it would be negative 2 to the first. Then we're going to add again, and we're going to say 3. And this time, we are going to say x to the first. We're still going down. And then our b is going to be raised to the second. And then lastly, we're going to say plus 1. And this would be x to the 0. And our b is going to be raised to the third. So x, your a terms, that goes down. So you'd start with your highest. If you're 3, it's going to start with a 3. So 3, 2, 1, 0. Then your b goes up exponent-wise. So 0, 1, 2, 3. Okay, so then we go to simplify that. So x minus 2 to the third. Okay, so technically, we would have negative 2 to the 0. This is going to become a 1. So we have 1 x to the third times 1. Negative 2 to the first is going to become still negative 2. So we have 3 x squared times negative 2. Negative 2 squared becomes 4. So 3x to the fourth times 4. And then plus 1x to the 0. Negative 2 to the third becomes a negative 8. So we go to simplify that. 1 times 1 is 1. We're just going to have x to the third to start out with. 3 times negative 2 is negative 6. So we're going to have a minus 6x squared. 3 times 4 is 12. So we're going to have a plus 12x x to the fourth that's not x to the fourth, that's x to the first. That's a 1. So plus 12x, and then we're going to have x to the 0 is going to go away. So we have plus a negative 8. And if we go to completely simplify that again, x to the third minus 6x squared plus 12x minus 8 is going to be your expansion on that. Okay, so now we have x plus y to the 7. Again, x is going to be a, y is going to be b, 7 is going to be n. If you need to label that, go ahead. Binomial theorem. Make sure you have that written somewhere that you can always reference it. So step 1, identify. So that means we're going to go, since this is 7, we're going to go to the 7th row. So 0, 1, 2, 3, 4, 5, 6, 7. These are going to be our numbers here. So our numbers are going to be 1, 7, 21, 35, 35, 21, 7, and 1. So those are going to be our coefficients. So x plus y to the 7th equals, and we're going to have 1 x to the 7th, and our b, we'll have y to the 0, plus 7 x to the 6th, y to the 1st, plus 21 x to the 5th, y to the 2nd, plus 35 x to the 4th, y to the 3rd, plus 35 x to the 3rd, y to the 4th, plus 21 x to the 2nd, y to the 5th, plus 7 x to the 1st, y to the 6th, and then plus 1 x to the 0, y to the 7th. Combining that all together, we're just, the y is going to go away here. We're just going to have x to the 7th. So we have x plus y to the 7th equals x to the 7th. Then we're going to have plus 7 x to the 6th y, plus 21 x to the 5th y squared, plus 35 y to, or x to the 4th y to the 3rd, plus 35 x to the 3rd y to the 4th, plus 21 x squared y to the 5th, and then continuing down here, plus 7x y to the 6th plus y to the 7th, because this x goes away. And that is the binomial theorem. So this will be loaded on Schoology. You will have practice problems on the worksheet, which I will add to the directions for the worksheet. You're not going to do the word problems. I want you guys just to focus on the binomial theorem. We're not going to do the word problems. Just expanding on the binomial theorem is all I want you to focus about with this section. Your homework is page 220, and it's 2 through 18 even. 2 through 18 even, page 220.